Okay, let's continue on chemistry part. Now I changed motion to part 5 because we had 4 clips prior to this, and then we still continue from where we left off on the redox process. I think we had a detailed discussion about gaining electron, losing electron, and the charge or the oxidation state. After losing electron, we do no longer call oxidation state, we call charge. Alright, of the species, either atom of different elements will change. You gain electron because electrons are -1 charged particle. For the neutral atom, gain electron, and the charge or oxidation state or the charge on the number line will move from right hand side to the left hand side, decrease. Then that is the reduction of the value. That's where the reduction term comes from. And then, or you gain electron, and in most cases, oxygen react with other species and steals the electrons too out of a neutral atom of another kind, another element, and then itself the oxygen become negative charge because the electron is negative charged. You gain 2. So normally 99% of a compound with oxygen related, the oxygen will show a 2- charge as a anion. Alright, so but if you lose electron or gain electron, what do you become? So it's no longer the same status of the species before the reaction or before the process. We call redox. Reduction and oxidation. Redox, right here, redox. So I try to make a concise table, so put everything in shorthand and everybody can understand or have something to review with. So I list the table as important concept on reduction, oxidation, or simply called redox. It's a more common term from any chemists. Alright, they all know what that mean, what it does mean. The processes. Alright, why is it processes? Because reduction is one process and the oxidation is another. Right? So here I list the process. And the process, the first one is a reduction we talk about. So what is reduction? Upon what kind of species are able to go into the process or take the process, alright, as reduction. Everything, right? So we can put here the atom, of course, is neutral, right? Or otherwise we won't call it atom. Or ions. Ions could be, alright, positive or negative, the anion, cation, anion, right? And it could be molecules, right? Binary, right? Compound, or just one atom, or the one element involved, right? It's called a monoatomic and molecule as well, all right? And a lot of molecules, organic molecules. And then the last way is compound. Is that possible? We find out, all right? Compound, right? So the action, when we talk about redox process, the redox process is nothing but involve the electron transfer. The electron transfer process. Now, who take what kind of transfer of electrons, gain or lose? That's what we talk about here. Reduction is defined as whoever it is as a species involved in the process will gain electron. Gain electron. Or gaining electron. I put apostrophe S, could be 1, could be more, right? Electrons. Gaining electron is the action the species took or takes, right? So what is the result? So we gain electron. Because electron is a negative charged particle, right? So it become what? It become reduced. It become reduced. Right? What does that mean? Reduced. The species, for instance, atom. Atom being reduced, right? Being reduced. So it's no longer 0 charge neutral atom. It become the value of the charge become negative side, from 0 to the next side of the number line. So become what? Become less, and has a charge, right? Charge reduced towards the left hand side of the number line. Right, now this means what? It's not necessary from 0 to negative value, or from positive 2 to 0. It could be from positive 2 to start with was a cation and become positive 1. Still cation, but the value on the number line moves towards left, right? So it's going to be like this, towards negative infinity on the number line, right? On the number line, right? On the number line. Let's say this number line right here, 0, then that's half of it, right? Number line, right? Then after you being reduced, what status of this species become is changed, right? Become what? Become what? It's being gain electron being reduced, then it become what? An oxidizing agent. Now what the oxidizing agent does, it means because the electron from this species getting stolen or lost, right? Or you gain electron, you stole somebody's electron, in this particular case called reduction. And then you take electron from somebody is not gaining electron but losing electron. So be what? If it's losing electron, it will become oxidized. Then who did that? This species did taking electron away from that species. Then that species getting oxidized, so this species become the oxidizing agent. Do the job of oxidizing somebody else. So what are you? 2, right? To be able to, let's say, able to oxidize other species in the same redox process. All right, that's the first. If we can have a small review afterwards. All right, after we finish this table. Come on. Okay. All right. Now that's the first process. The second process we call oxidation, right? Oxidation, reduction, oxidation. So the second one, the oxidation. Oxidation process, right? Oxidation process. Right? All right. The same species will be able to do this process is atom, same thing, right? Atom, iron, molecule, right? Iron, possible, and then cation iron, right? Molecule. And the compounds. Right? We'll have some example right here. All right, now the action on electron. We talk about redox, always involve electron transfer. So what the species here do what to the electron? This reduction is gaining electron. The oxidation is what? Losing electron. Now, Losing electron releases from who? Losing electron from itself. Alright, now the gain electron, we should put it here from what? Gain electron from what? From others. Is that there, look? Yes. So losing electron, right? What's the result? You lose the electron, right? Right, being what? Become oxidized. Becomes oxidized, right? And then the charge, right, of the or the oxidation state, all right, and then the charge or oxidation state all right will move to the left, to the right hand side. Oops. Right hand side. All right. Of the number 9. So let's say positive towards the positive infinity that side. Let's just put 0 in the middle, which doesn't mean really this half, the other half as well. So this is going to be the negative infinity right here. Right here we could put negative infinity, and could be the positive infinity right here, right? And but it moves this way. Right, move this way. It's reduction. Right, reduction anywhere. Go this way, right? Right. But here, go this way. That's why you don't say only from towards the 0 or towards the it could be passing 0 towards the larger positive value. Say start from positive 2, become positive 7. That happens all the time. Just give you instance, one instance is the manganese, right? So it could be plus 7, plus 2, or plus 4. It has 6, 7 different oxidation state values. Now this is called the oxidation. Now what happened after this happened? After this occurred? So this species, after losing electron, become what? Become a reducing agent. What the reducing agent does? The reducing agent do what? Be able to what? To give the electron, right? Right? To lose its own electrons to other species in the same process. Same process, right? Same redox process to what? To reduce their charge, let's put here, charge or oxidation state. Alright, so that is the whole thing. Alright, that is the whole thing. Alright, let's have a small review. It's just like a twist your tongue to say, you know, Peter, Pecker, whatever you. I was not born here and raised here, I don't know that, but you know what I'm talking about. say, okay, if you have process called reduction, it happens, whoever going through reduction will gain electron. So that gain electron negative sign, the negative charge particle to be reduced. The charge or oxidation state will going towards the left hand side of the number line, and itself, right, gain electron from who? From others, right? So others will be oxidized. So it becomes an oxidizing agent, right? So with the opposite, to the contrary, the oxidation process is atom or ions, right, losing its own electron from itself, right? And they become oxidized, right? Which means the oxidation state or charge will move from the left to the right hand side on the number line, right? And so after that takes place, this species, by losing electron to who? Losing electron from itself, right, to others, right? So we put here to others. To others, right? To others. To reduce somebody, because you give somebody negative particle, somebody's oxidation state or charge will getting net value adding to, the value will be reduced on the number line towards the left hand side of the number line, and that is called reduction. So these two are paired up. So we are able to understand, that's a one-time review. So for the shorthand, we are able to say reduction is gaining electron. Whoever goes through reduction is gaining electron, become reduced, has more negative value of physicals of the oxidation state, and itself become an oxidizing agent. If whoever on the other side, anybody goes through oxidation process will lose electron and get oxidized, but it become a reducing agent. So here we are able to say this. We can make it, highlight it. A reduction, right? And the gaining electron, right, become reduced and become an oxidizing agent. Now remember these four. And the oxidation, we're losing electron, right, and become oxidized, and then become reducing agent. Now, are those 8 terms simpler, easier to remember? I think so. So that's what we want you to get. All right. Now, okay, so let's conclude. We basically finish the small section, and now we expand it to the very, very big scope, including redox, which is much complicated in general chemistry learning and even teaching, because in our syllabus, let's point out. All right, let's point out. I'm not going to hide what I feel. My feeling is this is the most important concept we have to go through. We have to teach, but our syllabus try to de-emphasize redox process. Check the syllabus. It says so. De-emphasize. I don't understand what de-emphasize means, but I think this should be more emphasized, not de-emphasized. More emphasized, because you need to know this concept at the beginning, so you have more chance to be exposed and get over with and understand completely. Then you are able to deal with the later chapter. There's a couple of chapters involved the electron transfer process, especially on electrochemistry, right? And also in the future, we change the definition of redox for a little bit, which involve oxygen and hydrogen in organic chemistry part. So we need to get this over, right? Over our head. All right, so we understand this. Now, let's get into the next part. Since we already finished iron, that's the iron part. We've done iron. Now let's get into molecules, all right? So the molecules, let's see. Now, molecules, when we talk molecules, we have something to emphasize at the beginning. All right? In millions of compounds, or there are entities we call individual particle of compound. We sometimes call them molecules. But not all the substances, right? in the invisible microscopic world can be called molecules, because some of them don't fit into the definition of molecule. Molecule is a species that can be separated, right? Naturally, right? Into individual particles, right? With different number of atoms from different number of elements if it's compound, or from more than two, or just one atoms out of one single elements. That's called monoatomic or elemental molecules. But some of the species won't be able to do that naturally by itself. Those are a big category, has a huge number of compounds involved. Those are called ionic compounds. So we have to be very careful when we call the species molecule, or have another term we call formula units of ionic compound, which is a lengthy formula units of ionic compound. The 5 words. Here is molecules in 1 word. But these two terms are not interchangeable. Alright? We have to be very careful. Now, I am not teaching high-level chemistry. Now we are teaching the entry-level chemistry, general chemistry at the beginning, right? So we need to set up the foundation correctly. So when we build up something on top of the foundation, it won't crumble. Right? The building won't stand for too long, it will crumble, and you'll get a problem, right? So we try to set up the foundation firmly, correctly, and then you build your knowledge of chemistry on top of the foundation, you'll be alright. Okay, so molecule. How many types of molecule, right? How many types of molecule we are able to deal with, right? We are able to deal with at least 4 different types. Alright, you may say, okay, they are the same. No, they're not. So let's say molecule, right? Types. So first type, right? Let's say first type is a monoatomic right? Monoatomic molecule. So what is a monoatomic molecule? What we have, you only have my notes, right? So I can go fast because you all have my notes. You can confirm that notes I sent you about a week ago, right? Monoatomic molecule. So the first kind is the, we sometimes people call elemental. Elemental molecule. Right? With only one atom of an element. Now the situation of this is noble gas, right? Now example with noble gas molecule, they are naturally existing in the atmosphere. For noble gas, right? In the atmosphere, right? And you say argon, so you say G. The physical state is a G, right? Gas, right? Or you say neon, also G, right? Now that's the first type. The second type, the metal. Sometimes metal were commonly recognized as the sea of electrons. They have a lot of electrons because metal is electrically conductive. Very, very good conductor. And then the light electron transfer the current through one end of a wire to the other end of a wire. So there's a lot of electron hand to hand is transferred energy, and then at the speed of light inside those metal, and then that is because a lot of electron is free inside the atom of metal species, and then move around the carrying around the current going around. So that is conductivity. Now those were called, so example also, metal, say zinc, we say solid, that's a single metal, which is only one. It can be considered as a molecule in the chemical reaction equation writing. Zinc, and you may see copper, Cu, a solid, the gold, all kind, right? Those were only one, right? One atom out of certain elements, but probably only these two kinds. Sometimes as well, you can say, but it has to be possible. It's not necessarily all, but also non-metal are out of place. So example non-metal, right? Non-metal also, right? Non-metal, right? Non-metal, some of them, right? You consider as one, but not very many. All right, we're gonna talk about. Okay, now let's erase this. Right? Okay, I think it's already started erasing. Okay. Then, after the monoatomic, we have diatomic. Right? There's a lot of diatomic molecules from non-metal. But this is very rare. All right. The second type is going to be diatomic. Diatomic molecule, right? We have a lot also we consider as elemental, right? So you may have diatomic molecule. Oh, diatomic is going to be 2 right here. 2, right? And the first is also 1. It's elemental, right? It's also elemental. 2. Let's say 2. 2 atoms from the same elements in most of non-metals, right? Non-metals, all right, in a gaseous state. Right, form molecule. So the example is going to be hydrogen gas, right? H2, because hydrogen atom itself very rare to be able to stabilize in the atmosphere, all right, and it forms a diatomic molecule, right? It's more stabilized, has a lower energy, so that is what happens in the atmosphere. We have a very small amount of hydrogen, less than 0.0% of hydrogen, within the 1% of real gas and water vapor and carbon dioxide, carbon monoxide, methane, and then the oxygen, all right. Also, and then that's we have to breathe on oxygen, right? And the hydrogen. Now this is a diatomic molecule between 2 hydrogen atoms with a single bond, involve 2 electrons with spin opposite status and form a single bond we call sigma bond. They overlap their electron clouds. We're going to talk about this in the later on time for atomic structure and the bonding. And the oxygen involves 2. All right, about 2 electron bonding, 2 electron bonding and a double bond, and then in total is the 4 electron involved in bonding, the bonding construction. And then we have a chlorine gas, right? Nowadays, chlorine gas is very essential to save our lives because we are using bleach, right, to clean a lot of items at your household, and then the ingredient is the chlorine gas, or generated from the hypochlorite. All right. So these are diatomic molecules. All right. Almost all the gases we talk about. Then we have more oxygen and nitrogen. We put another one, nitrogen gas, behind it also. Now compare this with the noble gas. There's only one. There's no subscript 2. Subscript 2 on the right-hand side, lowercase, because there's only one atom representing one molecule itself. So time's up, and we continue for part 6. Continue on for molecules, and we probably will involve double bond, single bond, and triple bond a little bit